Hi friends, welcome to the Unit 1 Day 6. In this video we're going to go over solving rational equations and some examples that I provided here. So with these rational equations, our goal is to essentially get rid of the part that makes it a rational equation. It's a rational equation because it's a fraction. You have a fractional component. In this case we have x minus 1 and 3 in the denominator. So if I think about what do I need to multiply to get rid of a 3 and an x minus 1 in the denominator? Well, I need to multiply by 3 and x minus 1. And I need to do that to both sides of the equal signs. A lot of students miss this part. Make sure that you're multiplying it on both sides of the equal signs. So I am multiplying by a 3 and an x minus 1 on both sides. Another way that I can think about this is I'm multiplying by 3 and an x minus 1 on both sides. In this video, you're going to see me use the two different colored pens, and my goal in here is to show that with this problem, with these problem sets, we're essentially trying to keep separate what we're multiplying on both sides, which I'll use green for, and then what the original part already was, which I'll use blue. Purple. Bluish purple. So here we have a 3x minus 1 over 3, and then minus 2x over x minus 1. And then equals. Now with the x term, I'm also going to multiply it by a 3 and an x minus 1. And the original value is x. I don't need to use a set of grouping symbols for the right-hand side because it's just an x, but I do need to do so for the left-hand side because of the two terms there separated by that minus sign. Now we're going to have to remember that minus sign is important as well. And so as we go through this, I want you to kind of envision what this looks like when you multiply or when you distribute through. If I distribute, and let's just focus on these terms separately. Remember, multiplying it doesn't matter what order you do. So I could say, oh, well, I'm going to multiply the 3 through everything first, and then the x minus 1. Or I can multiply the x minus 1 through for both terms, and then the 3. So let's think about, when I multiply through by an x minus 1, it's going, by the 3. Let's do the 3 first. When I multiply through by the 3, this 3 term is going to cancel out or eliminate with the 3 term here. You'll have a 3 in the numerator and a 3 in the denominator, and those cancel because 3 divided by 3 is 1. So when you multiply through this term by 3, it doesn't actually change the value of 3x minus 1. That will still stay the same. That will still be 3x minus 1. I no longer have that 3 in the denominator because it canceled out. Bear with me. And then if I multiply through the other side, this negative 2x by 3, then I'm going to have a negative 6x. I went ahead and took that negative sign and carried it over to the 2x. I'm essentially distributing it at this point. So if you wanted to go back and change this to plus to a negative 2x, that's fine. All right, now I've taken care of the 3. Now I do the same thing with the x minus 1. So when I take the x minus 1, I need to multiply it by the 3x minus 1. So I need to multiply this 3x minus 1. I need to multiply it by an x minus 1. So going back to what we already have here, I should have left some space. So this 3x minus 1 is going to be multiplied by an x minus 1. And then this x minus 1 is going to be multiplied by this side. Now again, remember, x minus 1 is going to cancel with that x minus 1. Those two are going to cancel out. So I'm just left with that negative 6x that we established from earlier. I'm going to go ahead and leave these two in parentheses because I need to multiply those through. And then on the right-hand side, I'm going to go ahead and multiply through 3x minus 1 and x. Remember, order with multiplication. Do what's easiest for you because order doesn't matter. You can use the commutative property. So I'm going to take 3x here times x minus 1. We'll go ahead and simplify both of these multiplication parts now on this step. So 3x times x is 3x squared. 3x times negative 1 is negative 3x, negative 1x, and then positive 1. And then here I have a minus 6x. And then on this right-hand side I have 3x squared minus 3x. Now I need to clean up. Essentially I need to go through both sides. So here I've got 3x squared and 3x squared. If I subtract 3x squared from both sides, those are going to eliminate or cancel. And then I also have a negative 3x and a negative 3x on both sides. Those also are going to cancel out. Now, a lot of students get confused when you cancel everything out on one side. You don't know what's left. Well, literally nothing's left. The mathematical number for nothing is 0, so we have 0 left. So here I have negative 1x or negative x. Minus 6x is negative 7x. Plus 1, and then on the right-hand side we have 0. Subtract 1 on both sides. And then I have negative 7x is equal to negative 1. Divide by negative 7 on both sides, and you get x equals 1/7. Now, earlier we talked about being possible solutions. This is an example where we want to go back and check what the domain is. What are my allowed solutions? So again, going back to the domain of this problem, again, grabbing a new color, orange, I'll put the domain. I can have any number I want except for when I divide by 0. Now this situation here, what number would make that divide by 0? 1, you're exactly right. So I can have any real number I want. So I'll have x, so we're going to say x, the set of x's, such that x is not equal to 1. So as long as our solution set is inside the domain, we're okay. X equaling 1/7 is inside the domain. That is perfectly fine. So that's okay, and that is a valid solution. Join me in the next video where I go over the second example problem.